You have to know that a type of channel depends on channel transition matrix. Channel transition matrix. So in the channel transition matrix, there is a rows and columns are there. The rows and columns specifies the elements of the input and output. So channel transition matrix, it is known as P of y by x. P of y by x. So there is x are the inputs and y are the outputs. So x is n m number of inputs are given, and y is n number of outputs are taken. M number of inputs are given in the channel input. N number of outputs are taken in the channel output. So there is a relation between M and N. So in this channel diagram, so there is input X and output Y. Input X is X1, X2, X3, and X4. And output is Y1, Y2, Y3, Y of N. Okay, there is P of Yj by Xi is a conditional probability or channel transition matrix or channel transition probability. So you can arrange the matrix by using all the probabilities. That is known as channel matrix. That is P of Y by X is equal to P of Y1 by X1, P of Y2 by X1, likewise. So in the previous class, in detail, discuss on channel transition matrix. That is, X1 is the input, Y1, Y2, Y3 up to Y of N are the outputs in the first row. The first column is Y1 output, X1, X2, X3 up to X of N are the inputs. So that is the condition. Okay, now there is rows and columns in the matrix. So by using that matrix, you can classify the channels. So the matrix of the channel, if the output is known, P of Y is equal to P of X into P of Y by X. P of Y is equal to P of X is the input matrix and P of Y by X is the channel matrix. So now we can, you want to know the output of the channel, then so that is called P of X in the diagonal form, and P of Y by X is the channel matrix. Okay, now the diagonal arrangement of the input is the diagonal places only P of X1, X2, and X3, X of M. The remaining all elements are zeros. That is the diagonal arrangement of the matrix. For this matrix, multiplied with into 4 categories. One of the channel is lossless channel. Another one, second one is deterministic channel. The third one is noiseless channel. Fourth one is binary symmetric channel. Okay. The lossless channel, it is the property of lossless channel is in the channel transition matrix. One non-zero element in each column. Okay. So there is number of columns are there. In each column, one non-zero element takes place. Then that is the lossless channel. So if the lossless channel, for example, there is 3 by 4, 0, 0, 1 by 4, 0, 0, 0, 1 by 3, 0, 0, 2 by 3, 0, 0, 0, 1. Like, take an example, this is the channel matrix. So in this, the row sum should be the ion. The row sum should be the unity. Okay, now, so the non-zero element in each column and row sum should be the unity. So that's why if the one-off element is 3 by 4, another element is 1 minus 3 by 4, that is 1 by 4. If the one of the element is 1 by 3, another element is 1 minus 1 by 3, that is 2 by 3. Likewise, you can identify the elements based on the condition. Okay, now if that can draw the channel diagram, likewise x1, x2, x3 are the inputs, y1, y2, y3 up to y5 are the outputs. So like there is x1 y1, x1 to y2, there is a path. And a deterministic channel is the channel is defined as the channel transition matrix, only one non-zero element in each row, and the row sum should be the unity. In the previous channel, that is the last channel, one non-zero element in each column, whereas in the deterministic channel, one non-zero element in each row, one non-zero element in each row, and the row sum should be the unity. So that element should be 1. That element should be 1 because of the row sum should be the 1, and in the row only one element is there. That is one non-zero element in each row, and the element should be the 1. That is the condition of deterministic channel. So in that example, you can take one example there. 1 0 0 1 0 0 0 1 0 0 1 0 0 0 1. Like this is an example. And if you P of y is equal to P of x into P of y by x, no? So there is in the column 1, 2, 3, 4, 5 elements are there, and this matrix multiplication row should be the 5 element. Then only the matrix multiplication is possible. That's why what is the row? The row should be the P of x. The P of x is the input matrix. Input matrix and output matrix always in the row matrix. Input and output of the channel is specified as the row matrix. So that's why the input is x1, x2, x3, x4, x5. So and multiplied with the P of y by x. P of y by x the channel transition matrix. That is, let us example, this is the 1 0 0 1 0 0 0 1 0 0 1 0 0 0 1. So that's why P of y1 is equal to x1 into 1 plus x2 into 1, and P of y2 is equal to x3 into 1 and x4 into 1, x3 plus x4. P of y3 is equal to only x5. That is simply a matrix multiplication takes place here. Simply a matrix multiplication takes place here. That is P of y1 is equal to x1 plus x2, and x3, x4, x5 are the zeros. P of y2 is equal to x1, x2 are the zeros, x3, x4 are ones, and x5 also 0. That's why P of y2 is equal to x3 plus x4, x3 plus x4, and P of y3 is equal to x1, x2, x3, x4 are zeros, and x5 only 1. That's why P of y3 is equal to x of 5. Now you can draw the channel diagram. In the channel diagram, x1, x2, x3, x4, x5 are the inputs. Y1 and y2, y1, y2, y3 are the outputs. So then x1 to y1 is an output, no? Y1 is nothing but P of y1 is equal to x1 plus x2. That is P of y1 is equal to x1 plus x2. P of y2 is equal to x3 plus x4. P of y3 is equal to x5. So it is a channel diagram. And today you go for another channel, that is noiseless channel. So the noiseless channel have the properties of lossless channel and deterministic channel. Lossless channel and deterministic channel both are having the property nothing but that is a noiseless channel. Noiseless channel is the combination of lossless and deterministic. So what is the lossless channel condition? One non-zero element in each column. Okay. What is the deterministic channel condition? One non-zero element in each row. Is it not? So there should be one non-zero element in each column and one non-zero element in each row. And the row sum should be unity. The row sum should be the unity. So absolutely that element should be the one. Because of the row sum should be the one. In that row, only the one element is taken. One element is there. That's why that element should be the one. That element should be the one. Okay. So that's why in the first row, one element is there. In the first column, one element is there. Second row, one element is there. And second column also one element is there. Third row, one element is there. Third column also one element is there. Fourth row, one element is there. Fourth column also one element is there. That is why it obeys lossless channel means, noiseless channel means it obeys the properties of lossless channel and deterministic channel. Noiseless channel, properties of lossless channel and deterministic channel. That is one non-zero element in each column and each row. One non-zero element in each column and each row. The row sum should be the unity. The row sum should be the unity. So that's why the example of lossless channel, noiseless channel is a unity matrix. Unity matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So that is P of y by x is equal unity matrix. That is the noiseless channel. So then it should be a squared matrix. It should be a squared matrix. So 1 2 3 4 1 2 3 4. So that is 4 by 4 matrix. So noiseless channel should be a squared matrix and one non-zero element in each column, one non-zero element in each row. That should be the unity matrix. That is the unity matrix. So now let us see that the multiplication of input and output. P of x is into P of y by x. That is P of x is equal to x1, x2, x3 and x4. So that is multiplied with this. x1, x2, x3, x4 and multiplied this means. So how it is x1, x2, x3, x4 multiplied with 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So what is that? So P of I1 is equal to x1, P of I2 is equal to x2, P of I3 is equal to x3, P of I4 is equal to x4. So that is the channel diagram is x1, y1 x1, y2 x2, y3 x3, y4 x4. That is, there is no sharing of the path. Only the single path is there from input to output. So that is the noiseless channel. There is no noise. That means there is no loss, and it should be determined. That is, current input is current output, or current output is current input. Likewise, so it is the noiseless channel. Noiseless channel is it obeys lossless channel property and also deterministic channel property. So that is y1 is equal to x1, y2 is equal to x2, y3 is equal to x3, y4 is equal to x4. That is current input is taken to current output. Okay. So that is the noiseless channel. Noiseless channel. And the fourth one is binary symmetric channel. Binary symmetric channel. In the binary symmetric channel, it is defined as two inputs and two outputs. Two inputs and two outputs. The channel is symmetric because the probability of receiving 1 if a 0 is sent as the same the probability of receiving 0 if a 1 is sent. So this common transmission probability is denoted by P. What is the common transmission probability? If 0 is input, 1 is output. If 1 is input, 0 is output. Because of there are two inputs only, 0 or 1. If the 0 is input, 1 is output. If the 1 is input, 0 is output. That common transmission probability is known as P. That is the probability. What is the P? 0 by 1 or 1 by 0. 0 by 1 or 1 by 0. That is the okay. So that is the probability 0 by 1 or 1 by 0 means 1 is input, 0 is output, 1 is output. Excuse me. Zero is input, one is an output. One is input, zero is an output. That is a common transmission probability, that is P. And other probability is 1 minus P. What is the other probability? Zero is an input, zero is an output. Or 1 is an input, 1 is an output. That is other probability. If the one other probability P, second probability is 1 minus P. Because of this, there are two probabilities only. If the another probability P, another probability is 1 minus P. That is, probability sum should be the unity. That's why let us draw the channel as binary symmetric channel. It is the binary symmetric channel. It is the binary symmetric channel. X1, X2 are the inputs. Y1, Y2 are the outputs. If X1 is, X2 is 1. If X1 is 0, X2 is 1. And Y1 is 0, Y2 is 1. X1 is 0, X2 is 1. Y1 is 0, Y2 is 1. So Y is an output, X is input. Now there are two inputs and two outputs, 0 and 1 or 0, 1 and 0. If suppose 1 is an output when 0 is an input. 1 is an output, 0 is an input. That is 1 by 0. That is 1 is an output, 0 is an input. What is the probability? The probability should be P. The probability should be P. And 0 is an output, 1 is an input. 0 is an output and 1 is an input. What is the probability? The same as the P. Now, the counterpart, if 0 input, 1 output, if 1 input, 0 output, that probability should be the P. The probability should be the P. Another probability means 0 input and 0 output. That is 1 minus P. Y1, X1. Y2, X2. What is Y1? 0. Opposite probability is P. The same probability is 1 minus P. This is the common transition property of binary symmetric channel. Binary symmetric channel. So that's why you can arrange the channel matrix. You can arrange the channel matrix. P of y by x is equal to P of y by x is equal to P of y1 by x1, P of y2 by x1, P of y1 by x2, P of y2 by x2. Students, once again note down the elements in the P of y by x channel matrix. The first element is P of y1 by x1. Second element is P of y1 by second element is P of y2 by x1. First element is P of y1 by x1. Second element is P of y2 by x1. In the third element, that is P of y1 by x2. The fourth element is P of y2 by x2. What is the first element? We have y1 by x1. What is y1? This is the y1. What is the x1? This is x1. So what is the probability? 1 minus p. Because of the first element is we have y1 by x1. The probability is 1 minus p. And second element is p of y2 by x1. This is p of y2. This is the x1. What is the probability? The probability is p. The probability is p. What is the third element? P of y1 by x2. P of y1 by x2. So this is y1. This is x2. What is the probability? P. This is P of y2 by x2. So what is the probability? 1 minus p. Now the binary sequence channel matrix is 1 minus p, 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 and 1 minus p. There are 4 elements. So now, I mean, it is also a square matrix. 2 inputs and 2 outputs are there. It is also a square matrix. So now, P of y is equal to P of x into P of y by x. So P of x is a 2 element surname, x1, x2. x1, x2. Then P of y1 is equal to P of x1 into 1 minus p plus P of x2 into p. That's why P of y1 is equal to 1 minus p into x1 plus p into x2. Like P of y2 is equal to P of y2 is equal to P of x1 x1 into p plus 1 minus p into x2. That is p into x1 plus 1 minus p into x2. So that is the binary symmetric channel. Binary symmetric channel. Okay, students, classify the 3 channels, 4 channels in the in our curriculum. Those classifications depends on channel transition matrix. Channel transition matrix. Channel transition matrix have rows and columns are there. So that the first element and second element likewise. So then classify the lossless channel, deterministic channel, noiseless channel, and binary symmetric channel. Lossless channel is the channel if the channel transition matrix have the one non-zero element in each column and the remaining all elements are zeros. And deterministic channel is if one non-zero element in each row and remaining elements are zeros. Okay. And the row sum should be the unity. The row sum should be the unity. And noiseless channel. The noiseless channel is the channel. It obeys the lossless channel property and deterministic channel property. That is one non-zero element in each column and each row. So that channel transition matrix should be the unity matrix, and binary symmetric channel. In the binary symmetric channel, there are 2 inputs and 2 outputs are there. The inputs are x1 and x2, outputs are y1 and y2. Inputs are 0 and 1 is given, outputs are 0, 1 is taken. If the 0 input, 1 output, the probability p. The 1 input and 0 output, again the probability p. The opposite probability, the remaining probability is 1 minus p. That is 0 input, 0 output, 1 input, 1 output. That is a binary symmetric channel. The binary symmetric channel draw like this: x1, x2, y1, y2. So that is x1 to y1 and x1 to y2, and y2 to x1 and y1 to x2. That is the case. 1 minus p, 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 1 minus p. This is the binary symmetric channel. Okay. All this is simply a matrix multiplication only. If you are aware about the matrix multiplication, easily done the problems. Okay. So students, please note down the problem. Given a binary channel shown in below, given a binary channel shown in below, Number 1, find the channel matrix. Find P of y1, P of y2, when P of x1 is equal to P of x2 is equal to 0.5. That means P of x1 is equal to 0.5, P of x2 also 0.5. And third one, find the joint probability when P of x1 is equal to P of x2 is equal to 0.5. So students, note on the problem. Given a binary symmetrical channel shown in below. Number 1, find the channel matrix. Find the channel matrix. Second, find P of y1, P of y2 when